Hello, this is section 8.1, video notes, and on this chapter is multiplying and dividing rational expressions. So we need to identify our concepts, our objectives, and our vocabulary. So we have two objectives. We're going to simplify a rational expression and simplify a complex fraction. But in order to do that, we must define them. We must know what the definition of they are. So let's look at rational expression. What is a rational expression? Basically, it's a ratio of two polynomials. So what does that mean? That's pretty broad. So let's look at what is a ratio. A ratio is just a comparison of two numbers that can be written in fraction form. So for instance, 1/2 is a ratio, 1 to 2, comparison. What's a polynomial expression? Well, we got to know what a polynomial expression is. So a polynomial is, an example, x plus 1, or x squared plus x plus 2. These are all polynomial expressions. So a rational expression is simply the ratio of two polynomial expressions written in fraction form. Okay, so let's look at the examples. Let's go straight to the book and look at the examples, starting with example 1. So we said this is also an example. 1700, if you look at the book, 1700 over d minus 3 is an example of a rational expression. Because variables, so a polynomial is going to have variables, because they represent some real number, the operations of real numbers also apply to the operations of rational expressions. They're pretty similar. So, for instance, reducing a fraction. To simplify a fraction or reduce it, we divide both the numerator and the denominator by their greatest common factor. For example, 8/12. We divided both by 4, or we factored it out and cancel them out, which does the same thing. You're dividing by the greatest common factor, and we get 2/3. Look at this. So this is a rational expression because it's got two polynomial expressions. So we first factor, and we see that x minus 1 and x minus 1 are the same factors, and they cancel out. And we're left with x minus 3 times x minus 5. Now, this is where it's important to know what is the difference between a factor and a term. So basically, a factor, you've got multiplication going on. Okay? In a term, you have addition and subtraction going on. So 3 times 6 times 5 times 4 is all one, they're all factors. Factor times factor times factor times factor. X squared plus 3 plus 2 minus 1. These are, I have 4 terms here because they're separated by pluses or minuses. Now, whether they're like or not like is a whole different story. But we need to know the difference. So in this case, they're all factors, which means we only have one term because we don't have a plus or minus separating them. Here we have 4 terms, and if you look at each term by itself, it only has one factor. Now, it can be x squared y plus 7x. Well, now we can say that we have 2 terms here. This one has 2 factors, and this one has 2 factors as well. So that's going to be the key to, that is the key to fractions. So in order to do rational expressions, you must know fractions. Let's look at the example 1. They want us to simplify. So we're first going to simplify this 5x times x squared plus 4x plus 3. So we will have to write the problem out. Then we're going to factor. Okay, so this is times, so I've got 2 factors here because there's 2 numbers times each other. This becomes x plus 3 times x plus 1. Okay, then we have x minus 6 times x minus 3 times x plus 3. So it's important to understand on the numerator we have 1, 2, 3 factors, all times each other. We have 3 in the bottom. So in order to reduce or divide by the same thing, they have to be exactly the same. Just because these both have 3, these aren't the same factors, right? You have to think of it as a number has to be exactly the same, and it's tied together because of the minus and the division sign. But what do we have here? We do see that we have x plus 3 and x plus 3. So we divide both the numerator and denominator by that. Is there anything else alike? No. So everything else just gets multiplied back. And we have to know that parentheses and a number outside of it implies multiplication, just like a number next to any letters imply multiplication. And that is simply your answer. Now, we have a fraction, so we have to, and we have variables, so we have to determine under what conditions is this expression undefined. Well, it's a fraction. When is a fraction undefined? It's undefined when the denominator is equal to 0. So I have to go back to the original problem, and I see that I have 3 factors, and each factor has a variable in it. So I must take each one of those factors and equal them to 0 to find out when will, because remember, this is a number times, so it's like A times B times C. If any one of these are 0, any one or more of these are 0, the whole denominator is going to be 0 because anything times 0 is 0. So we have to find out what will make this expression equal 0, this expression equal. So we set them all equal. It has to be the original, equal to 0, and we solve when we get x equals 6, x equals 3, and x equals -3. So we have to know that this expression will be undefined at these 3 variables. If x is any of these, it will make the factor 0, which would make the whole denominator 0. Okay, so let's look at example 2. So they've got here, they want to know for what values is this undefined? Well, it's a fraction, so it's only undefined when the denominator is 0. So I have to take the original problem and take the denominator, which is 4x times x squared plus 6x plus 8. Now I need to factor it. So x plus 4 times x plus 2. So I have 1, 2, well, this is times each other. So I've got these factors. So I'm going to set each one equal to 0 to find out when it's undefined, because if any one of these are 0, it's going to make the denominator undefined. So here I divide by 4 and I get x equal, when x is 0, obviously. The 4 is not going to really matter or change anything. X equals -4, and I'm just doing algebra. And x equals -2. So this is undefined when x is either 0, -2, or -4. It will make that 0. Okay? So let's look at another example of simplifying rational expressions. Now, sometimes we need to factor out a -1. So let's look at this example, example 3. So we have w times, I'm going to go ahead and factor it as I'm writing it. So w times 4w, I factored out a w, and I'm left with 4w minus 3y, you can't factor anymore, times w plus y all over 3y minus 4w times 5w plus y. So I've got 3 factors in the numerator, 2 in the denominator. But none of them are exactly the same. But these 2 are similar. They're different by what? Their signs are exact opposite for both terms. So I can factor out a negative. It doesn't matter. I can do the numerator, the denominator. But because it's technically correct to have the negative in the numerator than in the denominator, I'm going to factor out from up here. So I have w. I'm going to factor out a negative from this term. So I'm going to get -1, which changes both of them to their opposites. So then I'm going to rewrite it to say 3y minus 4w times w plus y. Because it's factor times factor, I'm just factoring out of this factor here. So remember, I don't distribute negative to everything because it's 1 per factor. So then I have 3y minus 4w times 5w plus y Now these are exactly the same. They cancel out. Nothing else cancels out. So then I go ahead and multiply this back. And it's okay to leave it like this without FOIL in it. And that is your answer. Okay, so that's when we sometimes divide out a negative. Now, the methods for multiplying and dividing fractions, we said, also work for rational expressions. So look at example 4 that says, let's multiply this 6c over 5d times 15cd squared all over 8a. Now, if you go back to the book, they give you a nice little summary here. So when we multiply fractions, we do numerator times numerator over denominator times denominator. And what they did here is they prime factored each number. So you have 2 times 3 times 5, which is 15, and then 3 times 3 times 2 times 2. And in fractions, if we do it this way, we can just cancel out every factor in the numerator and the denominator. They're exactly the same, and they equal 1. And then what's left, we multiply it back. So after we simple cancel, we end up with 5 over 3 times 2, which is 5, 6. Now when you divide fractions, you keep the dividend, you change the sign to multiplication, and you change the divisor to its reciprocal. Or basically you take the dividend times the reciprocal, or the multiplicative inverse of the divisor, which is the same thing as its inverse. So they do that first, and then they use the multiplication rules of numerator times numerator, denominator times denominator, canceling out. So we apply the same thing to rational expressions. So let's look at example. So this key concept box kind of just sums how to multiply and divide fractions and expressions. So we have 6c 5d times this. So we're just going to rewrite to say 2 times 3 times c times 5 times 3 times c times d, which this is a long way. That's why our last, we have to know how to simplify exponents using exponential properties. All right, so then what happens here? Our 2's cancel out. We have a 5 that cancels out, a d that cancels out, nothing else. So what are we left with here? We're left with what? 9c squared d all over 4a. Okay, that's as far as you can go. Let's look at example B. So it says 18xy cubed divided by 7a squared b squared, divided by 12x squared y all over 35a squared b. First thing we do is we want to keep, change, flip, before we try to factor or simplify, because otherwise we need to have our original problems to make sure that we've got it correctly. So now we can just do what? 9 is 3 times 2 times x times y times y times y times 7 times 5 times a times b all over 7 times a times b times b times 2 times 2 times 3 times x times x times x. And if you don't know how to factor, then you need to get some help or tutor or come see me. This is important, so I'm not doing that on this video. So now we just simplify, cancel out anything that's the same. We have an x, a y, a y. We have an a, a b, a 7, a 7, and we're left with 3 times 5, which is 15, y squared. Be careful to be neat about this. We're left with a b and a 2 and an x, so 2bx, and there's your answer. Okay, so now sometimes it's necessary to factor both the numerator and the denominator before we simplify each expression. So let's look at example 5. And it says x squared minus 16x, or 6x minus 16 all over x squared minus 16x plus 64 times x minus 8. And again, use parentheses so you don't lose a sign, change the operation, mix up stuff, mix up different expressions, different factors, because with the division bar, they are tied together. So it helps keep you organized. So the first thing I need to do is multiplication. So I don't need to do any keep, change, flip. So now I'm going to factor out. So I've got x minus 8 times x plus 2 over x minus 8 times x minus 8 times x minus 8 times x plus 2 times x plus 3. Again, you've got to know how to factor or you're not going to be able to do this problem. So now we cancel out any factors that are exactly the same, sign and all. So when we cancel out, we end up with 1. So it's really important. We're really dividing both the numerator and denominator by a greatest common factor. So when I divide both these by x minus 8, I get 1 for each one. So what are we left with on top? All 1. So 1 times itself a million times is going to be 1. And then x plus 3. That is our answer. Multiplication is pretty easy. Now, when we're doing division, we want to make sure we write the problem out first. 12y plus 36 divided by x squared minus 12x plus 32 all over y squared minus 3y minus 18. A little messy here. So the first thing I want to do, I don't want to try and factor. I don't want to try and simplify. I want to keep, change, flip. So if I have a mistake or I'm trying to check my answer, it's easy to go back and see where the mistake was. Okay, because if you do it in your head, you're probably going to make mistakes. So now we're going to factor each one. X minus 8, or x minus 4 times x plus 4 times y minus 6 times, and this is 18, not 8. I wrote the problem down wrong. Minus y plus 3 all over. I'm going to factor out a 12 here, so I'm left with y plus 3 times x minus 8 times x plus 4. So now I can look, does I have anything the same? I have an x minus 4 and x plus 4. That's not the same, different sign. They're conjugates, so they're not equal. But this one and this one are the same. I have a y plus 3 is the same, so then I'm left with just what? X minus 4 times y minus 6 over 12 times x minus 8. Again, you can leave it in this format. There's no reason to separate. Now let's get to the second half of this chapter, section, and it's simplifying complex fractions. So let's define. What is a complex fraction? The very formal definition is a rational expression with a numerator and or a denominator that is also a rational expression. So basically, you can say, do I have an expression with more than one division bar? If so, it's a complex fraction. So to simplify, we must first rewrite it as a division expression, because remember, 3 over 6 really can also say 3 divided by 6. It's important to understand the numerator. Which one's the numerator? Denominator. This is also the dividend and the divisor. So we have dividend divided by divisor. Once you get that, then it's really easy. So look at example 6a. So we have a plus b over 4 all over a squared plus b squared over 4. I have an expression, a rational expression, with more than one division bar. So I'm going to rewrite this. First of all, identify numerator, dividend, denominator, divisor. So a plus b over 4 divided by 8. Don't try and do the keep, change, flip in your head, because you're going to get it wrong. Now I can say a plus b times keep, change, flip Now I use my fraction rules. This cancels out. Now, can I factor a squared plus b squared? No. Remember, we don't have a property that says that can't be factorable. If I had a minus, I'd have a difference of perfect squares. Then I can do a plus b times a minus b times a plus b. And then I can simplify. But this can't factor, so all I'm left with is a plus b over x squared plus b squared. So why you put it in parentheses, they're tied together. These factors are not exactly the same. Even though they have the same letters, just the squares are different. They cannot be factorable or simplified. That is your answer. Let's look at this next one, this last example. X squared over x squared minus y squared all over 4x divided by y minus x. So what do I have going on here? I have a complex fraction because I have an expression with more than one fraction bar. Got several. So identify numerator and denominator. That's the easiest way to do that. Then we can rewrite it as a division problem. Again, I'm going to parentheses each term if it's a binomial or higher. Over y minus x. So now I can do x squared over x squared minus y squared. Keep, change, flip. Now I need to see if I can factor this. So running out of room here. So this is a difference of perfect squares. So I have x minus y times x plus y times y minus x over 4x. Oh, do I have any of the same? Well, this can be written as x times x. However, looky here. They're just opposite. So I'm going to factor out a negative. So I'm going to rewrite this over here. So I'm going to rewrite it x times x times, I'm going to factor out a negative 1, which changes the whole sign to this entire expression or term. So it becomes x minus y all over x minus y times x plus y times 4 times x. So now I'm going to go and this cancels and this and this cancels and this cancels and this cancels, and I'm left with negative x all over 4 times x plus y. And you can leave your answer in this format. All right, do problems 1, 3, and 5, and we'll see you in class.